great. So I'm actually going to be talking about databases in general, since that's what I've been working a lot on Amplify is dealing with. Well, it's not really a large database. Like the data set I'm working with is a few hundred gigabytes, but you know, a lot of the stuff that I'm doing is to make sure that it works well at terabyte, well, like at terabyte scale, and hopefully in the future maybe exabyte. But you know, I think that's probably going to be a sharded strategy at the exabyte scale. Anyway, so this talk is going to be mostly about just like general guidelines and suggestions to optimize your database, and basically just how to make a solid, fast database. So yeah, you know, like I said, like big databases, they can get slow pretty fast, and with the incorrect data structures, you can get queries even locking up with like a few gigabytes worth of rows. So you know, at the end of the day, you're going to need a decent amount of RAM, like no matter what. But even at terabyte scale, if you have the indexing structure, if you have indexes structured in a way efficiently, that is, you can still have fast queries even with like 16 or 32 gigabytes of RAM. And another thing is having subqueries is also a great way to, you know, really reduce lock times on your database in general. So I think something that is pretty frequently discussed in just databases in general is database normalization. And there's basically there's like first normal form, second normal form, and so all the way to sixth normal form. And yeah, basically first normal form is when every column is just in one table, so it's extremely unstructured. And then sixth normal form is just the complete opposite, where every column is its own table essentially, and it's indexed in its own table. So you know, first normal form, you're gonna have probably a smaller database in general, but and obviously sixth normal form is gonna tend to be a lot larger given the amount of indexing per column. But you can still have like a performant database even with second or third normal form. But this is mostly because like MongoDB, Postgres, and MySQL, these databases provide useful indexing tools to actually basically kind of replicate that sixth normal form efficiency that it has. Like essentially, when you put an index on, say, your MySQL or Postgres database, you're technically creating this sixth normal form kind of secondary column. It's just not explicitly shown in your database structure, and it's just shown as like an index for that table. So a large reason why sixth normal form in comparison to first normal form scales so well is because it leverages like integers for sorting and ordering data. And you know, I think a really good way to like a good analogy to understand why sixth normal form is so much better is just looking at the amount of bytes required to store a string in comparison to an unsigned integer. For that same 1 byte, you can store 30,000 values in an integer, whereas for a string, you can only store 1 character. So I think, you know, just that representation alone kind of alludes to why sixth normal form is so powerful, just given how efficient and how much smaller, you know, well, per index that you have to deal with, as opposed to, say, you know, indexing you know, a relatively large text file, for example. So when it comes to indexing strategies, there there's a few things you got to keep in mind. Like, when it comes to like big O notation and stuff, we all like, I think the supposition is that, O1 time complexity is the best, but when you're dealing with big data, oftentimes O1 can actually be like the worst, because if you're dealing with terabytes worth of data, O1 is actually like O1 time complexity, even though that's technically the most efficient when it comes to like actual queries. It's actually, if you're dealing with a terabyte data set, it doesn't even work. You can't even effectively use it because you're going to have no RAM, and then you're going to have to page to disk, and then basically you break your database. So I think a really good analogy to use is of why like you have to consider like other things other than time complexity. Is just the difference between like binary trees and hash tables. So like in post-trees, there's the B tree and the hash indexing strategy. And actually, usually the binary tree is going to outperform the hash because it depends on the size of the hash table. Like the hash table will outperform on a smaller data set, but the binary tree will outperform on a larger data set. And this is because the binary tree can traverse that data set in a ring buffer. And with a ring buffer, you don't need to store the entire data set in memory, and you can just, basically pipe data in sequentially, and, you don't have to run out of RAM scanning the the database. So that's just something to keep in mind. Like, you have to think about like how exactly does this indexing strategy, or like basically your scanning strategy, it doesn't have to be, a binary tree specifically. How exactly does it work, and like how much memory does it take to do a scan, and those kind of things? Because like I said with the hash table, hash tables are essentially unusable at terabyte scale, because you literally need a terabyte worth of RAM just to even use the index. So yeah. So I guess in conclusion, like general suggestions for you guys is like subqueries can help a lot for optimizing, more complex queries that, might want to take up a lot of RAM. And then, 6 normal form, it helps you structure your database to be highly performant. It's not that you shouldn't be against second or third normal form database structures. It's just, 6 normal form will make sure that you have an efficient structure. And another thing, avoiding indexing strings, indexing unsigned integers. Like that's, I think that should be a given, with just the analogy of how much you can store in a byte with a string versus an integer. And then, consider the scale of the table and how operations need to perform on the table. And like the example with the binary tree and the ring buffers, like you don't need to store the entire index in memory to do that. And oftentimes that'll outperform the hash table. So those type of things you need to consider too. So yeah, anyway, that's all I want to talk about. I know it's not about Amplify specifically, but I thought, it'd be nice to just share this information for the ArConf.